Welcome to MacGyver Engineering once again. Today we have an electric engine on the table and it has a problem. It is a part of another project, but since it has a problem, it is task in itself. I'm not going to talk about the project right now, what I'm doing. I will definitely share it when it will be ever accomplished. And the problem of this engine is that it gives you a really nice electric shock from time to time. It will be difficult to explain without your skin on the metal parts of it, but sometimes it works, sometimes it doesn't. You know that it's very unpredictable. That's why I still think there is a hope for this one as well. So how can I show this to you? Let's say I will take the 20k resistance range. Maybe it will work, maybe not. So you know, this is the best measuring multimeter that I ever had, but the quality of it, you know, you have to consult with Dave Jones from EEV blog, and he will definitely tell you what he thinks about, you know, this multimeter right here. But let's give it a chance. Maybe it will show the same way as it showed me before. No. Now it shows something. It's jumping all over the scale, but it shows something. Sometimes it doesn't show anything. But anyway, now you get the idea. The coils have a bridge to... you cannot see what I'm measuring actually. The coils have a bridge to the you know, to the body of the rotor. So we have 7k ohm to the rotor. It shouldn't be like that, but it's not really stable. As I said, sometimes it shows, sometimes it doesn't, and it doesn't have much to do with the leads, I hope. What I will try to do is to clean it. Okay, I have some soap, dishwashing, dishwashing, what I'm talking about. It's a quite, it's a for gel total, for basically washing your clothes. I give a quite substantial amount of it, like for a half laundry, for half a load of laundry into a washing machine, and I use hot water. It's cold in here, so yeah, basically we will see. And this is exactly what I'm trying to do. Basically put everything into it and scrub it a little bit with a toothbrush, and we will see what results we can achieve with that method. We'll test the leads. So, what do we have? You see this? Significantly dropped. So there is less than 2k resistance. From 7, it was 7 or something, now it's 1.5. That means that the water got there, and it, you know, it's conducting right now because it's dirty water. So what I'm gonna do right now is I'm gonna let it be like this for another 5 minutes. Then I'm gonna rinse it with hot water again, because this is just the amount of the distilled water I have. I need to get some more. As it usually is on my video, this is a couple of days later. I already forgot about these videos that I made about this one. I took one more attempt of cleaning it with quite aggressive thinner. This one dissolves basically wood varnish, and this was soaked in it for about 24 hours, and it didn't make any difference, meaning the resistance on the between the poles and between the body of the rotor is still there. So it has to be, you know, somewhere in the layers of this varnish that is on the motor. It didn't solve anything. The thing is that this varnish that they use for these motors seems to be as tough as the enamel on the wires itself. So I don't think there is anything could be used in that case. If you have any suggestions as to how could I get through this without rewinding entire engine, or if you have any ideas how could I isolate the core from the rest of the machine, then you know, leave it me a comment. Of course, I know it's almost impossible, and you know, it's always dangerous stuff, but well, I would take a risk and see what's going to happen. More videos coming soon.